Hello, my name is Yufei Chen, and my project's topic is performance analysis of OFDM simulation. So, for my uh, PowerPoint, there have some topics. One is the introduction, and the second one is the problems on the study, and the third one is the existing approaches, and the fourth one is the evaluation of results, and then number 5 is the conclusion. So for the introduction, so OFDM is a high-speed data transmission method, and its basic idea is to divide a given channel into many subchannels in the frequency domain, and then maintain oscillativities between each subchannel. So we have some problems. So the first one I want to talk about the time frequency synchronization. So for the OFDM system, so it's particularly sensitive to carrier frequency offset, and the frequency offset caused by distortion and Doppler shift will damage the orthogonality between the subcarrier of OFDM system. Therefore, both ends of OFDM system must be strictly synchronized, namely very high requirement for synchronization accuracy. And the third problem is maybe the reduced peak to average ratio. So we know that the peak to average ratio is one of the main weaknesses of OFDM system, and reducing the peak to average power ratio is an important point. So in the OFDM system, the instantaneous maximum value of the superimposed signal of all subchannels is the maximum peak power. The ratio of this power to average power signal is called peak to average power ratio, or peak to average ratio for short. So between these two problems, so we have like some existing approaches. The first one is the purpose of. So I want to talk about the purpose of the scrambling. So the reason why we need to do that is first, reduce interference between neighboring cells. The cell-specific scrambling code sequence is used for scramble at the transmitting end, and the receiving end performance is scrambling. Only the UE in the cell can decode the received information in the cell based on the cell-specific scrambling code sequence formed by the ID of the cells. And also, it can randomize the interference signal. And the second approach is the mapping. So there is a corresponding relation between information and the signal that represents it and the signal that carries it. This relationship is called mapping. The receiving end extracts the information sent by the transmitting end from the received signal according to a previous agreed mapping relationship. There are many ways of mapping between information and the signals, and the different communication technologies lie in their different mapping methods. In fact, the main purpose of digital modulation is to control the transmission efficiency. Different digital modulation technologies are distinguished by their mapping method, and their performance also determined by the mapping method. So the next I want to talk about some my project result. Now I want to run my project. So my project have some saved ways. So I generate 0 to 1 random sequence. Then I do a serial to parallel. And the next the mapping. Then I take a conjugate and oversample. And the next is IFFT. And next I add a prefix and a subcycle. And next is add windows. And then I repeat parallel to serial. Then I add multiple channels and add AWGN and repeat to serial to parallel. And the next remove prefix. And next is FFT downsampling and the solution mapping. Then I can get the error rate. So during in the project code, I have put some plot. So now I run the project. So from the bottom we can see that there are several parts, right? So the first one is a modulated scatter plot of the 1 to 0 randomly, and the second one is the right one. And from the bottom we can see that we can get the error rate that is around 1.87%. So, and back to the PPT. So they have two parts. One is at the QPS key method, and another one is a QM16 method. And I also compare the original signal OFDM symbol to the add CP and CS signal OFDM symbol and add window single OFDM symbols. So we can see from the plot that the original single OMD symbol has a smaller amplitude width than add CP and CS and add windows. So that means the OFDM symbol has a more balanced than after add something. And the next one, I compare the multiple channel OFDM signal with the signal channel of OFDM signals. So the two spectrums are very similar, so we can see they have the very similar amplitude, and their time samples are run with the same time. So for the multiply channel, so the main negative impact of the multipass on the channel is the intersymbol interference. So that means the intersymbol interference. So we can lengthen the symbol time and add the CP protection between symbols to reduce its interference. And the next part, I draw the plot compare with the unwindowed signal spectrum and the windowed signal spectrum. So we can see the unwindowed spectrum is more balanced than windowed spectrum. So after we add windows, so we can see the plots that from the start and end, so they have the very obvious change. Then during the middle of the most of the middle of time, so they just go on to be the balanced. So from the PPT and the plot I drive, so we can see the arrow between the different channels and the single OFDM is very small, but it cannot be avoided. So there still has a very small error rate. So we can get the conclusion of the OFDM simulation. So they have So for the advantages, it has a high spectrum utilization, so we can see from this and these two ports, and also has a good resistance to multipassing effect. So it's very obvious here. So so after we just add the more channels, the amplitude and the things does not change very much. And also it has the storing anti-fading ability. Also it has a very obvious disadvantages. So OFDM has a relatively large number of subcarriers, so it will result in a large peak to average ratio. And also OFDM system is more sensitive to time error and frequency offset error. So this is all my project process and results. Thanks for watching and listening. Thank you.